What if someone told you that life on Earth was the product of blind, undirected processes? And the notion of purposeful design in nature was destroyed by Darwin's theory in the 19th century? What if explanations for the genius of the animal kingdom were limited to natural selection and errors in the DNA code? And if schools taught that the origin of eagles, whales, and monarch butterflies was once determined by the luck of the draw in a genetic lottery? What if science insisted that the hypothesis of a creator is nothing more than a bedtime story, and reality itself is merely random interactions of matter and energy? How would you respond? Could you disagree with confidence and conviction? Now you can. The Design of Life Collection. In November 2011, Time magazine honored a miniature aircraft as one of the best inventions of the year. Designed to mimic a hummingbird in flight, the Nano Air Vehicle, or NAV, was developed by a team of engineers in Southern California. This prototype of an experimental surveillance drone is equipped with a video camera and can hover, rotate, and fly in any direction.
It's a sensational piece of engineering, really incredible work, especially when you consider that all the parts are encased in a package that weighs about the same as a AA battery. But in terms of its complexity and abilities, the NAV is still light years behind the bird that inspired its creation.
Hummingbirds have to be among the most fascinating birds I've ever encountered. Kind of made a lifetime avocation of studying them and filming them and getting to know them. There are 343 recognized species today, and all of them are found in North America, Central and South America.
Vibrant, beautiful, and wonderfully unique, hummingbirds are among the most breathtaking creatures on the planet. Often described as nature's helicopters, their acrobatic displays, powered by wings that can beat more than 100 times a second, are unparalleled in the avian world.
Hummingbirds are built for speed and maneuverability. Zipping around, incredible aerobatics, going backwards, forward, hovering in midair. The tail is a balancing organ. It helps guide which direction they want to go. They can raise it to zoom up. They can drop it to stall. They can use it to go side to side. It's highly maneuverable. The flight muscle in a typical hummingbird represents about 43% of the body mass. That gives them a tremendous power to do these kinds of maneuvers that most birds cannot even dream of accomplishing.
Hummingbirds routinely employ 3 specialized types of flight. To fly forward, the wings flap rapidly up and down, generating thrust. Then to hover, their angle and movement are radically adjusted to create a figure-8 pattern that stabilizes the bird's body in the air as it feeds. And to fly backward, the wings move in a circular path above the bird's head.
No other bird can fly like this because no other bird has a skeletal system designed to function like a hummingbird's. And this becomes obvious when you compare a hummer to a large bird like a raptor.
For a red-tailed hawk and virtually every other species of bird, the mechanics of powered flight are similar. Its wings flap up and down, like paddles on hinges, creating lift only on the downstroke. In contrast, while hovering, A hummingbird flaps its wings backward and forward to generate lift on both strokes.
Hummingbirds need to hover in a fixed position, meaning that they need lift all the time, and their shoulder joint provides a unique solution to the problem. It can rotate a wing 140 degrees by twisting the upper arm bone. And when the bone twists, the entire wing inverts as it's coming back up, actually to generate part of the lift that they require to maintain their stability in the air.
The hummingbird's rigorous lifestyle is also sustained by its muscular, metabolic, and circulatory systems.
To keep this massive flight muscle filled with oxygen-carrying blood, the bird's heart has to beat as much as 1,250 beats a minute. Just think of the speed of the nerve synapses. I mean, all of this is being controlled by nerves firing at an incredible rate to make this possible.
The hummingbird is fueled for flight by consuming more than twice its body weight in nutrients each day. So during its waking hours, the bird eats every 10 to 15 minutes. It has been estimated that to survive, an adult human being with comparable metabolism would require 150 pounds of food every 24 hours. The engineering demonstrated in the bird's anatomy is again ingenious.
The hummingbird's tongue is about twice as long as its beak, so it can reach deep into a flower. And until recently, many scientists believed that the birds relied heavily on capillary action to draw the nectar through their tongues and into their mouths. Kind of like water spontaneously rising up a thin straw in a glass. But some fascinating discoveries at the University of Connecticut have shown that the mechanisms involved are much more dynamic than anyone realized.
The hummingbird's tongue is actually a nectar trap equipped with a pair of narrow tubes that taper sharply. The tip of each tube is segmented into a row of flaps that are attached to a supporting rod. When the bird isn't eating, these flaps form two rows of closed loops that fit compactly into the beak.